So today, instead of doing notes together as a whole class, you are going to watch this video and you are going to complete your note-taking guide that was handed out to you. So on the front cover of that piece of paper, you have a review. And so in sixth grade, you guys learned about the water cycle. This week, we are going to be talking about water as a resource and the difference between groundwater and surface water and how we as humans use this. But to understand that, we have to go back to how did the water get there? And that is where the water cycle happens. And so, just as a review, we're going to go through this to make sure that we are all on the same page. Okay. And so, we can start with the ocean. So the ocean is the largest body of water on the earth. 75% of the earth's surface is composed of the ocean. The sun rays heat up the ocean, which causes evaporation. Evaporation is hot water vapor, which is then cooled down into condensation. And so wind and cool air make condensation. Cooler air then turns that condensation into precipitation, which is rain. That rain then runs off and into different rivers and different bodies of water. And so runoff water flows back into the ocean. And then we have transpiration, which we actually learned about in photosynthesis. That is the byproduct of cellular respiration, where as plants are getting energy, they lose water as a result. So the water cycle is the process in which water moves through the earth and the atmosphere. Okay, so now you're going to flip inside of your paper and feel free to pause this video at any point to take notes. Okay, so this is the paper that you should be looking at right now. And so as we go throughout the slides, this is what you should be filling in. Now, yours does have a little bit more words on it because I wanted to make it more fill in the blank to make it easier. Okay, so the first thing at the top left corner, we're going to look at H2O, where surface water happens. So precipitation and runoff are what causes surface water. Okay. And so surface water is any body of water that is above the ground. That could be oceans, streams, rivers, lakes, wetlands, reservoirs, creeks, literally anything, any body of water that is above the ground is known as surface water. Okay. So below that box, you have another box with arrows, and so it is just a key. So surface water and groundwater can feed each other. And so even though we are talking about two separate forms of water, they can both feed each other, which again allows the water cycle to take place. So now let's talk about groundwater. Groundwater is water that seeps deep into the ground, right? Hence the name groundwater. But how does it get there? So groundwater may be near the surface or it could be as deep as 3,000 feet, okay? That's why people are able to build wells in different places because they have a huge storage of groundwater. So let's look at this. So the different layers that help contain groundwater. At the top, we have soil, which kind of provides a layer not just for water, but also for the things to grow. You have the unsaturated zone, which is more of like a clay-like material. You have the capillary fringe, which is kind of a mixture of clay and rock material. You have the water table, and so that is the height of the water, where the water is stored. And then you have the saturated zone. And so the saturated zone is composed mainly of rocks because, as you learned in sixth grade, the deeper you dig into the earth, the more rocky it gets. Okay, so now let's look at both of these types of water together. So both surface and groundwater participate in the water cycle. Okay, which again is why it is important that you have a solid understanding of the water cycle so that you understand how it gets there and how it flows. So, one of our most valuable resources is water and the water cycle, which is why we have to take care of it and we have to make sure that we are using it as a renewable source. So, let's take a closer look at what both of these sources look like. So, here is a river system that we have above the surface of the water. If we take a closer look at it, you can see how that surface water then seeps down into the earth, and then we have the groundwater. Okay. So they both kind of feed off of each other. If we have less surface water, there is hope that there is still groundwater. However, if the surface water dries out, the groundwater will dry out as well. Okay, so let's talk about aquifers. We're actually going to have a lab all about aquifers on Friday, so it's really important that you understand what they are. So, aquifers are water bearing rocks that easily transmit water to springs and wells. The word transmit just means move. And so, these rocks have a porous like structure. And so, it's really good for holding in that water, and then it moves that water into springs and wells. And so they're essentially like huge storehouses of water connected over an area. So think of like a dish sponge. If you soak that dish sponge up with water, you can then carry that water somewhere else. That's essentially what an aquifer is, but underground. And so again, this is what makes springs and wells. Okay, so there are such things as natural springs. You can find them a lot of times in the mountains. And so as gravity is flowing down, you have those aquifers that allow springs to pop up, and then you can also have wells. But there are no underground rivers or lakes. And so that is something that is commonly confused. If we have this groundwater and this surface water, doesn't it essentially just make an underground river? No. Let's talk about that. And so, gravity, right? Gravity pulls water and everything else towards the center of the earth. So, we looked at this yesterday with our speaker from REWA. He talked about how REWA uses the gravity of the earth to help flow the wastewater into their pipes and into their facilities, which is why their facilities are on the southern end of Greenville, because that is the way that the gravity pulls. And so that is what prevents lakes and rivers from popping up underground, because gravity is constantly moving that water towards the center of the earth. So groundwater is very susceptible to pollutants. Susceptible just means that it is at risk of coming in contact with a lot of different pollutants. And so we have pollutants such as waste. That could be animal waste, human waste, also gasoline, anything from cars that might go onto the roads and then spill into the storm drains. Yesterday, we also learned about how storm drains go directly into the rivers. And so those types of water carriers do not get purified. They go right back into the river. And so everything that ends up on the ground is going to end up in the river. And so, where is Earth's water located? So, if we take a look, ice caps contain about 1.7% of the Earth's waters. And so, that could be glaciers and snow. And so, it is essentially stored water. And as it melts, the rivers and oceans around it rise. Only 0.001% of the Earth's water is in the atmosphere, and that's because of the water cycle. The water cycle is constantly moving that water around, so it doesn't stay in the atmosphere very long. 96.5% of the water is in the ocean, and so this is a lot of salt water that we have. And then 1.7% is in lakes, rivers, streams, and soil. And that would be the fresh water. Okay. So just a distinguishment between fresh water and drinking water, right? Fresh water doesn't always mean clean. It just means that it is not salty, okay? And so now you should have everything filled out onto your note-taking guide. If you do not, there is a copy of the notes right in front of you. And so you can pause this video if you need to, and you can finish copying down your notes. And then once you are done with this, you can then start to work on the activity where you are going to read about how we can use the ocean water, since it makes up 96.6% of Earth's water. How can we use that? Okay, I'll see you guys tomorrow. Bye-bye.